So I was looking at GitHub trends this morning, and it feels like we've officially crossed the Rubicon. It's January 2026,
Hmm.
and the dominant commit style isn't clean code or TDD anymore. It's vibe coding.
Vibe coding.
And honestly, I get the appeal. You throw a prompt at an agent, it spits out a React component or a backend service.
Mhm.
You glance at it, the vibe feels right, and you ship it.
It's the path of least resistance.
Yeah.
But, the old saying about the path of least resistance, it's usually downhill.
Right.
And right now, according to the report we're pulling apart today from the new stack, that hill leads directly off a cliff.
That is a cheerful start. But seriously, we need to talk about this report. It dropped on the 20th, and it's aggregating some heavy hitters.
Oh, yeah. David Mitton from Arcjet, Simon Willison.
Who obviously needs no introduction if you've ever touched Django.
For sure. And Aiden Warsaw from Mobb. And they aren't just, complaining about kids these days. They're talking about catastrophic explosions.
Right. And they are not using that term lightly. The central tension here isn't that the code is bad, per se. It's the trade-off. It's velocity versus what they call the blast radius, which is a terrifying term for software development. But let's be real, velocity is the currency of the realm. If I can use an LLM to clear my backlog in an afternoon, I'm going to do it. My PM is happy. My burn down chart looks amazing.
Of course.
So are these guys just yelling at clouds, or is there a specific mechanic here that's actually dangerous?
It's the mechanic of vibe coding itself. Let's define it properly, because it's not just using AI. It's a specific behavior.
Okay.
It's when you let the AI agent write the logic, and your review process is essentially, does it run? Does it look like it does the thing?
Yep.
You aren't building a mental model of the control flow.
You're just trusting the output based on intuition.
Exactly. You're treating the code like a black box.
Oh.
You care about inputs and outputs, but you've stopped looking at the gears.
And that works fine until the gears trip.
Precisely. And David Mitton points out that this is effectively the default mode of development now. Vibe-coded apps are everywhere in production.
Right now.
But Simon Willison dropped a comparison that really, it really stops you in your tracks. He's comparing the current state of AI coding agents to the Challenger space shuttle disaster.
I saw that, and I'll be honest, my initial reaction was, okay, Simon, dial it back. I mean, I'm building a series app, not a solid rocket booster.
It sounds like hyperbole at first.
Yeah. But then I read his reasoning about the normalization of deviance.
That's the key. The Challenger didn't explode because they didn't know there was a risk. They knew about the O-ring issues,
Right.
but they had flown before and it hadn't blown up yet. So they normalized the risk. Willison is arguing that we are doing the exact same thing.
With AI agents.
Yes, we are giving them what is effectively root access, or at least very, very high-level permissions, to execute code, install packages, modify your configs.
And because my laptop hasn't been bricked yet, and because AWS hasn't sent me a $100,000 bill yet.
You assume it's safe.
Right.
Precisely. You're confusing absence of disaster with presence of safety. Willison's fear is that we're letting these agents operate with practically zero guardrails because the feedback loop is so positive. Look how fast I built this. But the failure mode, he predicts, isn't a syntax error. It's a catastrophic failure in a core component that nobody understands.
Because an AI wrote it and nobody actually read it.
Exactly. That's the blast radius concept.
If I write a bug, I usually have a vague idea where the bodies are buried. But if the AI writes a bug in some complex hallucinatory way, I mean, debugging that is a nightmare.
It's worse than a nightmare. It's an archaeological dig. You're digging through layers of logic you never even designed.
Okay, but let me play devil's advocate here. David Mitton, he's a CEO. He runs Arcjet. He's not a Luddite. He's not saying turn off the computers.
Not at all.
So surely there's a middle ground where we get the speed without the explosion.
There is, but it requires a level of discipline that vibe coding usually lacks. Mitton proposes what he calls a safe list. It's basically triage for how you use AI.
Okay, let's break that down. What's allowed on the safe list?
First up, prototyping. This is the obvious one. If you're building a proof of concept, throwaway code, go nuts.
Right.
The blast radius is 0 because it's never going to hit a customer.
If my hackathon project crashes, nobody dies.
Exactly. Second is the editor role.
Yeah.
This is where you use the AI for discrete, reviewable tasks. Refactor this function to be more readable, or rename these variables.
Okay, small diffs.
The diff is small. You can look at it and instantly know if it's right or wrong.
That's how I mostly use it. It's like a really smart sed command.
And that's safe.
Okay.
The third one is the most nuanced. Constraints. If you can box the AI in, you can let it write code. For example, if you tell it, implement rate limiting using the Redis SDK, you are safe-ish.
Because the SDK itself enforces the behavior.
Right. The AI can't invent a new, broken way to talk to Redis if you force it to use the standard library methods. The boundaries are set by the tools, not by the LLM's imagination.
The problem is, developers are terrible at sticking to boundaries. We love the happy path. And that brings us to the most interesting and, honestly, kind of mind-bending part of this report.
The debate.
The debate between Mitten and Eaton Warsaw regarding legacy code.
This is where the plot really thickens. Mitten has this golden rule: don't invent.
Okay.
AI should never, ever be allowed to invent security mechanisms from scratch. No custom crypto, no homebrewed auth patterns.
Which is standard engineering advice, AI or not. Don't roll your own crypto.
Correct. But with AI, the temptation is higher because it looks so confident. It will happily write you a function called encrypt password that just does a base 64 encoding, Mitten says, only use validated components.
Makes sense. But then Eaton Warsaw comes in and basically says, hold on, even that might be dangerous.
Yeah, Warsaw introduces this idea of the security backlog as an active risk. And this really changed how I view technical debt.
Okay, walk us through this. Because usually when I think of my security backlog, it's just a pile of JIRA tickets gathering dust.
It's a passive liability.
Right. It just sits there until I fix it or someone exploits it.
That was true in the pre-AI world. But in 2026, your backlog is training data. Warsaw argues that when you use an AI agent, especially one with context awareness of your repo, it reads your existing code to match the style and patterns.
Oh, I see where this is going. It sees my garbage code from 2019 and thinks, this is the house style.
Exactly. It sees a SQL injection vulnerability you haven't patched,
Yeah.
or a deprecated auth flow, and it identifies that as an approved pattern. The AI wants to be helpful. It wants to fit in. So it just replicates your vulnerabilities in the new features it builds.
That's profound. So my technical debt isn't just sitting there. It's actively teaching the junior engineer, which is the AI, how to write bad code.
It turns your passive debt into active risk propagation. Warsaw explicitly says that adding AI features to an existing legacy application might be more dangerous than starting from scratch.
Which creates a massive paradox. The conventional wisdom is don't rewrite, refactor. But if I refactor with AI, I might be amplifying the rot.
It's the approved pattern trap. The AI validates its bad decisions by pointing to your own code. Look, boss, I did it just like you did over in the payment module.
So we're in a bind. We have the challenger risk of normalized deviance. We have the velocity trap. And now we have our own legacy code sabotaging us from the inside.
It's a tricky spot.
How do we actually defend against this? Because just be careful isn't a strategy.
No, hope is not a strategy. The report offers two very concrete technical defenses. And the first one is going to make some people groan and others cheer.
Let me guess.
It's about language choice,
Yeah.
Specifically Rust.
I knew we'd get to Rust. The Rust evangelists are going to love this. But why Rust specifically in the context of AI?
It's about the compiler as a gatekeeper. We all know Rust has a steep learning curve. The borrow checker is brutal. It screams at you for memory safety issues, concurrency problems, type mismatches.
Which is usually why people bounce off it. It's hard to write.
But if the AI is doing the writing, the hardness becomes a feature, not a bug. Mitten argues that if you vibe code in JavaScript or Python, the AI can generate code that runs but has subtle catastrophic logic errors.
Tight coercions.
All that stuff you won't catch until runtime.
Right. Undefined is not a function happening at 3 a.m.
Exactly. But with Rust, if the AI hallucinates a method or messes up memory management, the code literally will not compile. The compiler acts as a hard stop.
That's actually a brilliant reframe. You're outsourcing the frustration of the borrow checker to the bot.
Let the bot fight the compiler.
And you only get the code once it actually follows the rules.
It forces a baseline of technical correctness that interpreted languages just don't have. It's a safety net that you don't have to maintain manually.
But let's be real. Most of us aren't rewriting our stacks in Rust tomorrow, much as we might want to. If I'm stuck in a massive TypeScript or Python repo, what's my defense? I can't rely on the compiler to save me.
Then you have to change how you test. Mitten is really clear here. Unit tests aren't enough.
Why not?
Because unit tests assume you know the logic you're testing. If you didn't write the code, how do you write the unit test?
You just ask the AI to write the test, and then you have the blind leading the blind.
Precisely. The AI writes the bug, then writes the test that passes with the bug. The pollution is end-to-end testing. You have to treat the AI's output as a black box and test the behavior.
So not does this function return true, but if I click this button, does the money actually move to the right account?
Yes. You need to verify the outcome, not the implementation. And this ties into the verification protocol Mitten suggests. It's a workflow change.
Walk me through that.
Let's say you need to stop bot traffic on your login page. The lazy way, the vibe coding way, is to type fix bot problem into the prompt and just paste whatever comes back.
And it gives you a regex that bans anyone with a Gmail address or something.
Or worse, the verification protocol breaks it down. Step 1, instruct the AI to install a specific validated library, say a fierce rate-limiting middleware.
Okay.
Step 2, ask it to write the configuration for that library. Step 3, ask it to write a test case that specifically mimics a bot attack.
And then step 4, I assume, is verify.
Step 4, verify the block works in a staging environment.
So you're treating the AI as an implementation detail, not a consultant. You're doing the architecture, it's just doing the typing.
That is the crucial distinction. You provide the constraints, it provides the syntax. If you invert that, if you let the AI provide the architecture, you are asking for that explosion.
It seems like the theme here is constraints imply safety. We need to put these agents in a box.
It's a very tight box.
So let's wrap this up with some practical rules of engagement for 2026. We've covered a lot of ground, but if I'm deploying code this afternoon, what's my checklist?
I boil it down to 4 rules based on Mitten and Worzel's insights. Rule 1, scaffolding with validated components. Green light.
It's tedious work. Let the robot do it.
Exactly. Rule 2, novel security implementations. Hard red light. Never, ever let an AI invent a lock.
Got it.
Rule 3, treating the AI as an editor for small, reviewable changes. Green light. It's great at make this cleaner.
And rule 4.
And rule 4, which is the big one. Generating entire code bases or complex features from scratch, only if it's disposable. If you can't afford to throw it away, you can't afford to vibe code it.
That distinction, disposable versus durable, feels like the thing we're all ignoring. We're building permanent infrastructure with the mindset of a hackathon.
We are, and I want to circle back to that Challenger analogy one last time because it haunts me.
Okay.
The O-rings on the Challenger failed because they got cold. It was an edge case. The engineers knew about it, but the data said it's been fine before.
Yeah.
AI agents are happy path machines. They optimized for the average case. They don't think about the cold. They don't think about the edge cases.
And since we aren't writing the code, we aren't thinking about them either. We've removed the human friction that used to catch those edge cases.
Exactly. We've removed the friction, but we haven't removed the risk. We've just hidden it. And hidden risk is the most dangerous kind.
So the takeaway is pretty clear. Use the tools, enjoy the velocity, but don't let the vibe lull you into a false sense of security. Check your blast radius.
And maybe read the code. Actually read it.
That's a radical idea. Thanks for diving in with us. We'll see you on the next one. Stay paranoid.